Hi guys, today we're doing experimental probability, and the experimental probability is just the probability based on an experiment. So here's what this really means. So last time we did theoretical, and theoretical would be, so let's say that I have, a die here, and I want to know what's the probability of picking a 2. Well, the probability of picking a 2 would be 1 out of 6 times because this die has 6 different sides to it. So an experimental probability would be where I actually roll this die a bunch of times and then I keep track. I take a record of what I get. So I just got a 2. Oh, I'm getting up to 2s today. I got a 5. And I would just keep going and going and going until I get a whole bunch of different tally marks here. So you see, I just rolled this die 20 different times and I recorded what I got. So the experimental probability of picking a 2 would be I got a 2 3 times out of a total of 20, which is definitely not the same as 1 over 6. So experiment is where you actually take the results from an experiment. Theoretical is where you do what should happen. All right, let's continue on with these notes. So if you look here, I just said experimental probability is the number of times an event occurs over the total number of trials, which is what I just showed you with the die. So if you look here, we have a table that shows us the results of somebody spinning a spinner. First thing we need to do is we need to get a total. So I need the total. So to get the total, I'm going to add 6, 11, 19, and 14. And I get a total of 50. So somebody sat there and spun this 50 times. All right, so what's the experimental probability of spinning a 4? So again, experimental means we want to look at this because I should get it 1/4 of the times, but I got a 4 14 out of 50 times, and then you have to reduce that fraction to get 7 over 25. So again, that's experimental probability. If it was theoretical, it would have been 1 out of 4 times because a spinner would look like this and it would have 4 things on it. So it'd be, there's a 4, 1 out of a total 4 times. That's theoretical. All right, let's try another experiment here. Find the experimental probability of spinning an odd number. So I look at this table and 1 is odd and 3 is odd. So I want the probability pretty much of getting a 1 or a 3. So I'm going to get a 1 6 times. Or I'm going to get a 3 19 times out of a total of 50. So if I add those up, I get 25 out of 50. Make sure you reduce that, and that gives me 1/2. So half of the time I'm going to get an odd number. All right, let's try number 3. Find the experimental probability of spinning a number less than 4. So that means I want a 3 or a 2 or a 1. So I got a 3 19 times, or I would get a 2, I got that 11 times, or a 1 6 times. So that's what I want out of my total is 50. I add these up and I get 36 out of 50. Make sure you reduce that on a calculator or in your head, and that gives you 18 out of 25. All right, one more. Find the experimental probability of spinning a number that is not a 2. Again, this is experimental, so if I don't want 2, that means I want any of those other numbers. So a 1 or a 3 or a 4. So you're going to have to go through and add those up. You get a 1 6 times, you get a 3 19 times, and you get a 4 14 times. That's out of 50. And I get 39 out of 50, which doesn't reduce. So that's my answer. All right, so it's experimental probability. You're going to have to look at the results from an experiment. All right, here's another one. So again, this is dealing with cards. Last time, for theoretical, we always talked about having 52 cards and doing the probability here. But this time I've got to look here. This time I picked a card 5, 9, 7, and 5 times. So I picked a card this many times. I picked one, I looked at it, I looked to see what I had, and I recorded it. So I'd say, oh look, I got a diamond. Oh look, I got a club. I got another club. So I sat there and did this, I don't know how many times. I'd pick one card, I'd record it, that's 2 of them. Oops. Pick one card, put it back. So how many times did I do that? I'm not sure. We have to add these numbers up. So that's always going to be kind of your first thing, is to figure out the total. We don't always tell you the total. So 5 plus 9 plus 7 plus 5. So I picked a card a total of 26 times. So what's the experimental probability of choosing a diamond? So if you look, I got a diamond 9 times out of a total of 26. So you can try to reduce that. It's not going to reduce, so we are done. Now, what's the experimental probability of picking a card that's not a club? So I want everything except for that club there. So I want a heart, or I want a diamond, or I want a spade. So there's 5 hearts, or there were 9 diamonds, or there were 5 spades. So, all right, so I just filled those in, heart, diamond, or spade. That's going to give me 19 out of 26. So 19 out of 26 times I got heart, diamond, or spade. All right, moving on. I've got another table here that shows that I rolled a die, a number cube. Here I recorded it. I need to know the total. So the first thing I'm going to do here is I'm going to add up those numbers and get the total. All right, so I'm going to get a calculator out and I'm going to add these up. 11, 16, 14, 20, 12, and 17 to give me a total of 90. So I know that's going to be my bottom number. All right, find the experimental probability of rolling a 4. This is kind of like those first problems I showed you here. So if you look, here's the 4. I got a 4 20 out of 90 times. If I reduce that fraction, it gives me 2 over 9. Next one, experimental probability of an even number. So an even number is going to be 2 or 4 or 6. So I got a 2 16 times, I got a 4 20 times, or I got a 6 17 times out of 90. If I add those up, I get 53 out of 90. Try to reduce that, it doesn't reduce, so I am done. A couple more and we're done here. Experimental probability of spinning a number. Whoops, that should say rolling a number. Sorry, guys. Rolling a number greater than 2. So if I look here, I want numbers that are bigger than 2. So that means I want 3 or 4 or 5 or 6. So if I add those numbers up, let's see, 3, I get a 3 14 times. Make sure you don't add 3, 4, 5, 6. You add up how many times you get those. So 14 plus 20 plus 12 plus 17 out of 90 gives me 63 out of 90. Always check to see if you can reduce these numbers. So if I check 63 over 90, if you're not good with your reducing there, I get 7 out of 10. One more. I see I would fix that for you. Find the experimental probability of rolling a number that is not an even number. So if it's not even, that must mean that it's odd. So if it's not even, it's an odd number. So I'd want a 1 or a 3 or a 5. So you'd have to just add up those, number of times that you rolled those. So you got 1 11 times, you got 3 14 times, and you got a 5 12 times. Out of 90, add those up, and you get 37 out of 90. That one doesn't reduce, so we are done. All right, go ahead and try your homework now. I will warn you, there's some review problems on your homework. So you've got some of these experimental probability problems, but then you do have some review. So we'll spend another day reviewing, and then you'll have a quiz coming up. All right, see you later, guys.